Intel. It's a name synonymous with computing. For decades, they've been the driving force behind the processors that power our laptops, desktops, and even servers. From the early days of personal computers to the high-performance machines we use today, Intel's innovation has been undeniable. Their relentless pursuit of performance and efficiency has set benchmarks in the industry. But even with their iconic status, Intel has a bit of a reputation when it comes to their processor names. The naming conventions can be quite perplexing for the average consumer. To the untrained eye, it can feel like deciphering a secret code. The array of numbers and letters can be overwhelming. Core, i3, i5, i7, i9 generations, gigahertz. Where do you even begin? Each series and generation brings its own set of features and performance levels. Don't worry, it's not as complicated as it seems. With a little guidance, you can easily understand what each name signifies. This guide is here to break it all down, giving you the knowledge to confidently navigate the world of Intel processors. We'll explore the differences between the Core series, explain the significance of generations, and demystify the technical jargon. By the end, you'll be equipped to make informed decisions about which Intel processor best suits your needs, whether you're a casual user, a gamer, or a professional. You might think a processor's speed is all that matters, right? Just like a car, the higher the number, the faster it goes. Well, not quite. While clock speed measured in gigahertz gives you some idea of performance, it's not the whole picture. Think of it like this. A sports car and a pickup truck might both have powerful engines, but they're designed for different purposes. Similarly, two processors with the same gigahertz can perform very differently based on their underlying architecture and features. Intel's naming scheme, while seemingly complex, aims to provide a more holistic view of a processor's capabilities. It's about more than just raw speed. It's about understanding the intended use and overall performance potential. Let's dig a little deeper into why gigahertz isn't the be-all and end-all of processor performance. While gigahertz measures the clock speed of a processor, it doesn't tell the whole story about how efficiently a processor can handle tasks. Imagine two runners, both completing a mile. One might have a faster pace per minute, but the other might take fewer strides and conserve more energy. One might have a faster pace per minute, but the other might take fewer strides and conserve more energy. Processors work similarly. It's not just about how fast they can go, but how efficiently they can perform each task. A newer processor might have a lower gigahertz than an older one, but it could have architectural improvements that allow it to process more instructions per clock cycle. These improvements can include better instruction sets, more efficient pipelines, and advanced power management features. This means it can actually be faster, even with a seemingly slower clock speed. The efficiency of each clock cycle can make a significant difference in real-world performance, especially in complex tasks like video editing or 3D rendering. Furthermore, factors like core count, cache size, and integrated graphics all play crucial roles in determining a processor's overall performance. More cores can handle more tasks simultaneously, larger caches can store more data for quick access, and integrated graphics can offload tasks from the CPU. Intel's naming scheme tries to encompass these nuances, giving you a better sense of what to expect. For example, an Intel Core i7 might have more cores and a larger cache than an Intel Core i5, even if their clock speeds are similar. This helps consumers make more informed decisions based on their specific needs. To understand Intel's current naming scheme, it helps to take a quick trip down memory lane. In the early days, Intel primarily used model numbers to differentiate its processors. You had the 386, the 486, the Pentium, and so on. These numbers provided a loose indication of processing power, but it wasn't very consumer-friendly. Then came the Pentium era, where Intel introduced brand names to make things more relatable. We saw the rise of sub-brands like Celeron and Xeon, targeting different market segments. However, as technology advanced, this system became increasingly difficult to maintain. Section 5. Decoding the core. i3, i5, i7, i9. In this section, we will break down the differences and help you understand which one might be the best fit for your needs. Enter the Core series, Intel's attempt to create a more logical and scalable naming structure. This naming convention helps consumers easily identify the level of performance they can expect from each processor. This brings us to the familiar i3, i5, i7, and i9 designations. Each of these designations represents a different tier of performance, catering to various user needs and computing demands. Think of these as tiers, with each tier representing a different level of performance and features. The higher the number, the more powerful and feature-rich the processor. Core i3, the entry-level option, ideal for everyday tasks like web browsing, email, and light productivity. It's perfect for users who need a reliable and efficient processor for basic computing needs. Core i5, the sweet spot for most users, offering a good balance of performance for gaming, content creation, and multitasking. It provides enough power for more demanding applications without breaking the bank. Core i7, geared towards demanding users and gamers, providing higher core counts and faster speeds for intensive workloads. This tier is suitable for those who need extra power for tasks like video editing, 3D rendering, and high-end gaming. Core i9, the top of the line, designed for extreme performance in areas like professional video editing, 3D rendering, and high-end gaming. It is the go-to choice for professionals and enthusiasts who require the best performance available. Understanding these tiers can help you make an informed decision when choosing a processor. Whether you're a casual user, a gamer, or a professional, there's a core processor that fits your needs. From laptops to desktops, Intel's Core series processors are found in a wide range of devices, ensuring that you get the performance you need, no matter what type of computer you use. So the next time you're in the market for a new computer, remember the Core series and choose the processor that best matches your computing requirements. Section 6, Beyond the Core. Unpacking the extras, but wait, there's more. Intel's naming scheme doesn't stop at the Core designation. You'll also encounter additional letters and numbers that provide further insights into the processor's capabilities. Here are some key ones to look out for. U designed for ultrabooks and thin and light laptops, prioritizing energy efficiency for longer battery life. H high-performance processors commonly found in gaming laptops and mobile workstations. K unlocked for overclocking, allowing you to push the processor beyond its base clock speed for increased performance. Section 7, Generation Gaps. What a difference a year makes. As if things weren't complicated enough, Intel also releases new processor generations each year. These generations typically bring architectural improvements, new features, and sometimes even a new manufacturing process. You can identify the generation of an Intel processor by the first digit after the Core i designation. For example, a Core i7 13700 is a 13th generation processor, while a Core i5 12400 is a 12th generation processor. Generally speaking, newer generations offer better performance and efficiency than their predecessors. However, the actual performance difference can vary depending on the specific models being compared. Section 8, the AMD factor, keeping Intel on its toes. No discussion of Intel processors would be complete without mentioning their biggest rival, AMD. AMD has been making waves in the processor market with its Ryzen series, often offering comparable or even superior performance at competitive prices. AMD's naming scheme is similar to Intel's in some ways, with Ryzen 3, 5, 7, and 9 tiers mirroring the Core i series. However, AMD also uses different suffixes and generation numbers, so it's important to be aware of the distinctions. The competition between Intel and AMD is great news for consumers, as it drives innovation and pushes both companies to deliver better products. Section 9. So, which CPU should you choose? With all this information, you're now equipped to make more informed decisions about Intel processors. The best CPU for you ultimately depends on your needs, budget, and the tasks you'll be performing. For casual users, a Core i3 or i5 processor is likely sufficient for everyday tasks. Gamers will find that a Core i5 or i7 processor, especially one with an H or K suffix, will provide a good gaming experience. And for content creators, a Core i7 or i9 processor is recommended for demanding tasks like video editing and 3D rendering. Section 10. Beyond benchmarks, the bigger picture. While understanding processor specifications is important, don't get too caught up in the numbers game. Ultimately, the best way to gauge a processor's performance is to look at real-world benchmarks and reviews for the specific devices you're considering. Remember, factors like RAM, storage speed, and even the operating system can all impact overall system performance. A well-rounded system is about more than just the processor. Section 11. Intel's future, innovation and beyond. Intel continues to innovate and push the boundaries of processor technology. With each new generation, we see improvements in performance, efficiency, and features. From artificial intelligence to edge computing, Intel is at the forefront of shaping the future of computing. While their naming scheme might seem daunting at first, it's a reflection of the complexity and sophistication of their products. By understanding the language of Intel processors, you're empowered to make informed decisions and unlock the full potential of your computing experience.